This is the second video about section 5.2 covering right triangle trigonometry. Thus far, we defined the 6 trig functions using SOHCAHTOA in terms of the ratios of side lengths of the right triangle. Okay, so we'll have several trig identities that can be used to help us with our calculations, and that's what Theorem 5 is. So first we see the reciprocal identities, which I mentioned in the previous video. So cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. We also have the quotient identity, so you might notice that if you take sine over cosine, so this is opposite over hypotenuse over adjacent over hypotenuse. So the hypotenuse cancels and we just get opposite over adjacent. So that's why sine over cosine is tangent. Tangent is opposite over adjacent. And then cotangent, which is the reciprocal of tangent, must equal the reciprocal of sine over cosine, which is cosine over sine. So that's what this quotient identity is talking about. And lastly, we have the Pythagorean identities. So we know that, for example, sine squared plus cosine squared will be opposite. So we have some triangle, right? We have some angle. We have opposite, adjacent, and hypotenuse. So if I take sine squared plus cosine squared, then that simplifies to opposite squared plus adjacent squared over hypotenuse squared. And by the Pythagorean theorem, opposite squared plus adjacent squared equals hypotenuse squared. So this is hypotenuse squared over hypotenuse squared, which is 1. So that's this first identity. Sine squared plus cosine squared is 1, as long as the argument theta is the same angle inside of both. If you can just remember that one, then you can remember the other ones, because, like, for example, if I take this and if I divide both sides by cosine squared, then I would get sine squared over cosine squared plus cosine squared over cosine squared equals 1 over cosine squared. In other words, tangent squared plus 1 equals secant squared. And if you were to divide this by sine squared instead, you would get the third Pythagorean identity, which states cotangent squared theta plus 1 equals cosecant squared theta. I'm just telling you this so that it makes sense. And for me, I don't like to remember too much. I just remember enough, and then I can figure out everything else that I need without memorizing. Okay, so let's see a few examples of how we're going to apply all this. So in problem 4, we're given that theta is an acute angle, and the sine of theta is √3/2. The cosine of theta is 1/2. We're going to use identities, not a right triangle this time, to find each of the remaining 4 trig functions' values at theta. So I know both sine and cosine. Therefore, I can get tangent because by the identity, tangent is equal to sine over cosine. So that means that this is √3/2 over 1/2. So the 2's will cancel and we just get √3/1. So the tangent of this angle is √3. Okay, and then once I have sine, cosine, and tangent, I can use the reciprocal identities to get all of the other ones. So I know that cosecant is the reciprocal of sine. So cosecant equals 2 over √3. I know that secant is the reciprocal of cosine. So secant is 2 over 1. And cotangent is the reciprocal of tangent. So that equals 1 over √3. So without even having to use a right triangle, as long as I know both sine and cosine, I can use identities to find all of the remaining values. values. Okay, look at number 5. This problem asks us to find sine squared of 15 degrees plus cosine squared of 15 degrees. Since these are the same, 15 degrees is both the same, then I can use the Pythagorean identity. So by the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. That's it, just 1. So you just have to figure out which identity is the right one to use. I think that's probably the hardest part. Okay, so take a look at number 6. We have the sine of 13 pi over 9 times the cosecant of 13 pi over 9. Well, probably not going to be a Pythagorean identity because there's nothing squared. So we might consider the reciprocal identity to help us out. So I know that whatever cosecant is, it's the reciprocal of sine. And now we see that we have sine of 13 pi over 9 divided by itself. Easy cancellation. So this also equals 1 by the reciprocal identity. Okay, so let's see some more examples. In problem 7, we're given an acute right triangle with a hypotenuse of length 4 centimeters, and the side opposite the angle theta has length 3 centimeters. We're going to find the values of all trig functions at theta. So I can't use identities yet. I have to at least start by drawing a right triangle like before. So I'm given that the hypotenuse has length 4, and I'll choose theta to be this one, and we're told that the side opposite of theta has a length of 3 centimeters. So now I can label my adjacent side by A, and I can find A by using the Pythagorean theorem. So I know that A squared plus 3 squared is equal to 4 squared. So that means that A squared plus 9 is equal to 16. And so I can subtract 9 from both sides. So A squared equals 7. And by the square root, I got A equals root 7. Okay, so I know now all 3 lengths. And so for me, I'm going to do SOHCAHTOA to get sine, cosine, and tangent. And then I'll use reciprocal identities to find the other 3. So the sine of theta is the opposite side over the hypotenuse side. And so because of that, I know the reciprocal of sine is cosecant. So the cosecant of theta is equal to the reciprocal of 3/4, which is 4/3. Now I use the fact that the cosine of theta is the adjacent side over the hypotenuse side. And so by the reciprocal identity, the secant of theta is 1 over cosine 4 over root 7. Lastly, the tangent of theta is equal to the opposite over the adjacent, and the cotangent of theta is the reciprocal of the tangent. So this is how I can find all of the values of all of the trig functions of theta. Okay, so number 8 is pretty similar. We're just given a little bit of extra information to help us solve this problem. So in number 8, we're given an acute angle theta inside of a right triangle, and we're given that sine, which is opposite over hypotenuse, is equal to 2 over 3, and we're given that cosine, which is adjacent over hypotenuse, is equal to root 5 over 3. So we could have just used the sine and the Pythagorean to find that root 5 is the adjacent, but because we're actually given the cosine 2, it's easier for me to do it that way. And we are asked to find the values of the remaining trig functions. I already know sine and cosine, so tangent is remaining. So the tangent of theta is equal to 2 over root 5. So tangent equals opposite over adjacent. And then I'm just going to use the reciprocal identities to get everything else. So the cotangent is the reciprocal of the tangent. And I know that the cosecant is the reciprocal of sine. And the secant is the reciprocal of cosine. Okay, so that is how I can get all of the values of all the trig functions of that angle. Okay, just one more page with a few more examples to make sure that we really understand this well. Okay, so in number 9, we're given an acute right triangle with a tangent of 1/2, and we're asked to find the values of the remaining trig functions of this angle. So we know that tangent is, okay, sorry, my iPad just crashed again. I'll make one more video for the last page.